x1 plus 13y, and here we have minus 7x plus 16y. So here we have a vector which is 3 by 1, and this is operating on onto a vector which is 2 by 1. So this is the linear transformation, and the first thing that we might want to identify is what is the matrix. So always it is very helpful if we try to identify this A such that the Tx, so the linear transformation on x would be equal to xax. So this is what we always try to do, and in order to identify this one, we know that we have to first figure out what is A on 1, 0, okay, and then what is A on 0, 1. So we define this one, or we apply, sorry, this is wrong, this is T on 0, 1, and T on, on this linear transformation onto the standard basis, and this would be the first column of A. So this is the, so here we include all the rows and only the first column, and this is all the rows and the second column, and this is equal to the first column. If we apply here 1, 0, we get here 0, 13, wait, this is wrong, 0, minus 5, and minus 7. We have to look at the coefficient of x, and the second column of A, it will be 0, 1, this is 1, 13, 16. So simply, we obtain that the matrix A, which represents the linear transformation T in the standard basis, it is 0, minus 5, minus 7, the first column, minus 7, and the other column, it's 1, 13, and 16. So we have a matrix which is 3 by 2. Okay? Now, given this matrix 3 by 2, let's try to identify how this matrix of this linear transformation, how does this look like with respect to if we have a basis B, which is equal to 3, 1, and 5, 2, and we can have also another basis B prime, and this basis B prime, it has to be for the R3. So this B prime, we have here 1, 0, minus 1, and minus 1, 2, 2, 0, 1, 2. Now, what we need to conduct here is that so here we have the standard basis, okay, which is where in this standard basis we have a vector x, okay, and the linear transformation on x. So this is the vector x, this is the vector x, and then we have to look for what is the, so here we have to look for what is the vector x in basis B and the linear transformation on x according to basis B. In here we have to look for what is the linear transformation of x on basis B prime. This is what we denote here. And we now, so let's assume that the basis B is here. What are the relevant informations that we immediately need? What we immediately need is in fact that we go this way with matrix P, right? And we go this way with matrix P prime. If we use the similar notation, or we can call this one PB, and this would be the P of B prime. Now, this PB has to be the basis of R squared, which in principle, it is simply this, right? Because this is the basis. So then we can say that the PB is equal to a matrix, which is 3, 1, and 5, 2. Similarly, we might, as you might expect, is that here we're going to have the PB prime. This would be equal to all of these three vectors. We get 1, 0, minus 1, 2, 2. And here we get 0, 1, and 2. That's good. So we start like this, and then before going any further, it is always essential to find also the inverses. So here we have the PB. We may need to find what is the PB inverse, and here we have the PB prime. We need to find the P inverse of the B prime. The P inverse of the B prime, it is in fact, it is 1, 0, minus 1. Wait a second, no. This is 2 minus 1. This is wrong. This is equal to 1 over 3, 2 minus 1, 2, 2, 2 minus 1, minus 1, minus 1, 2. So this would be the P inverse of the B prime, and then the question is, we need to find the matrix M. So let's write. Wait a second. So we have the linear transformation and the so we want to find the matrix A with respect to B prime. Okay, so let's remind that this is what we want to find. We stated this one verbally, but just have a look at this statement here. So this is what we need to find, and these will be equal to this would be equal to the P inverse of the B prime times A times PB. Okay, and it is worth looking also at the dimensions. So if this is the P inverse of the B prime, this is this is 3 by 3, right? Because this is an invertible matrix, and the inverse of a matrix, it can be defined only for square matrices. So what is A? If we have a look at A is 3 by 2. So here we have the matrix A, which we found it in this section. So the values of A, we determine that in here. Then here we have the matrix A, which is 3 by 2. And then we multiply with the PB, which is 2 by 2. So here we have the PB 2 by 2. In fact, imagine for a moment, let's say that you got confused and you don't know which one you are going to multiply first. Here, in fact, there is no way. This is what A is. So A is 3 by 2. So there is no way you can multiply with a matrix which is 2 by 2 in front of it, right? So you might also conclude what the solution would be just by using your intuition. And this will help you a lot, especially if you are dealing with a non-square matrix. So finally, this is going to be equal to, so here we have, this is 1 over 3. One over 3 times, we have 2 minus 1, 2. 2 minus 1. And the minus 1, minus 1, 2. We can continue again, minus 5, minus 7, 1, 13, 16. And here we get the PB 3152. Okay, so this is what will be the, and as an answer, we get here, this will be equal to 1, 0 minus 2, 3, 1 minus 1. So this is an example of how a linear transformation can be represented with respect to two different bases in the case when the matrix is not the square one. Okay, any question? So next week or next session, we are going to start the more formal definition of the diagonalization using the eigenvalues and eigenvectors. Today, actually, we had the chance to see a direct application of the diagonalization with an example we solved in the second session of today's. But next week, we're going to go a little more in detail and looking at how the eigenvalues, the properties of the eigenvalues, the relationship of the eigenvalues with the determinant, the relations of the eigenvalues with the trace of a matrix, the geometric representation of the eigenvalues and eigenvectors, and many more. So next week, you can start getting ready for chapter 8. We're completely done with chapter 7 of the textbook. And yeah. Any question? If you have no more questions, we can end also this session.